this practice now more to estimate the median and the interquartile range. So let's just check our answers. Yes. Okay, answers. Hi. Okay, so for the median of A, you should be getting 62. And then for the interquartile range of A should be 18. Median of B should be 70. And then for the median and interquartile range of B, you should be getting 70 and 23. Okay? Any concerns in getting this median interquartile range? Are we able to get it? I trust that you did your work. Okay? I don't think we are at step 1 already that I really need to check on your work and all that. Okay? So, part 3. Okay, that's what I want to focus on today. Very typical statistics question, whenever they ask you to find median interquartile range, the follow-up question will be asking you to make sense of the information that you gathered. Okay, so later on when we do mean and standard deviation, okay, you also have to make sense of these numbers that we're getting. Okay, especially when we're trying to draw comparisons between different data sets. In this particular question, the context given to us is that we are looking at students from different schools and how much time they spend on revision. Okay? So in part 3, we want to state with a reason if students from school A or school B spend more time revising daily. Okay? So just a very quick recap about what we mentioned about mean, median, and mode yesterday. Okay, or in fact in set 2 itself, we recognize that mean, median, mode are measures of averages. Measures. Okay, so that's your mean, median, and mode. And then we also have measures of spread, whereby we have range that we talk about, interquartile range, and later on we also talk about standard deviation. Okay? Usually we don't discuss about range so much because range is very sensitive to your maximum and minimum. So if you have just one person who has a very low score or one person that has a very high score, it causes the range to be very big. Whereas interquartile range is better because it takes into account the middle 50% of people. Okay, so range we very rarely talk about it. We talk more about interquartile range. And interquartile range is usually being tied to median because median is where we look at the person that is right in the center, and then interquartile range is from the center, the 50% area around that middle person. Okay, so you can imagine in your mind like a circle with a center, okay, and then a certain radius. The radius in this case, okay, or the diameter in this case is your interquartile range. Okay, so you can have in your mind a mental image whereby you have your median, and then your interquartile range being your diameter. Okay, because interquartile range is whereby we look at the upper quartile minus the lower quartile. So it's a diameter. Okay. So in part 3, when we want to talk about which schools spend more time revising daily, we're looking as an average, as a whole. So when we're talking about average itself, we should refer or draw reference to the measures of average, and in this case, we're talking about medians. Okay, there is no way for us to determine the mean from a cumulative frequency curve. Okay, neither is there a way to determine the mode in a cumulative frequency curve. Okay, in a cumulative frequency curve, the only average that we can talk about is median itself. Right? So in this question, we're looking at as a whole itself, we refer to the average, refer to the median. So looking at the median values that we get over here, for school A, we have 62 minutes, and then school B, we have 70 minutes. That means that the students in school B, generally, okay, on average, they actually spend more time revising. Understand? So therefore, to actually answer part 3, we can conclude that the answer will be school B, but we need to provide the reason, and the reason that we provide is because of the median value that we find. Okay? So let me write down how to phrase that out. Conclusion, which is that the students at school B spend more time revising daily. So this is our conclusion that we have from the data whereby it provides the evidence, and the evidence is about the median, and you need to say that the median is greater for school B, as compared to that of school A. So when you do a comparison, I want us to have a good practice that don't just stop at saying that the median is greater. Please draw reference greater than what? Greater than who? Alright? Don't just stop at saying that it's greater. So always continue to say greater than that of school A, which is the comparison point that we have over here. Okay? Questions? Okay, yeah. Okay. Now we take a look at part 4, where part 4 says in which school is the daily revision time more consistent. Okay, we're looking for consistency itself, not so as a whole. Okay, so when we talk about consistency, actually we're looking at the spread. Okay, so looking at measures of spread, since we are discussing about median, or in fact in this question we also talk about interquartile range. So we make use of interquartile range, to make our conclusion over here. Okay, so we know the median over here. Okay, if the interquartile range is wider, that means that the students that have certain revision time, they spread out more from the median. Because interquartile range refers to the middle 50%, how much do they actually perform in this case? That means the daily revision time. So if you want something that's more consistent, that means towards the median, your interquartile range is narrower, smaller in size. So looking at the values that we have, we see that the interquartile range of A is actually smaller in value. So the daily revision time of the students in school A is actually more consistent because the range is actually smaller, closer towards the median. You understand? So in part 4, I'll just write here now. value, the more consistent it is. Okay? Right? So being more consistent, that means that if I really know the data values of the students in school A, right? Okay, the amount of time they spend on revision doesn't vary very much from 62 minutes. It doesn't vary so much from the median itself. Okay, unlike in part 2, for school B itself, with the median being 70 and the interquartile range being wider, that means the variation, the spread, okay, from the median 70 is wider. Okay, so maybe, okay, I'm just giving an example, okay, some random number, I'm unable to tell. Okay, maybe for the median, okay, there are people who can get maybe up to maybe plus 13, okay, 83, okay, significantly wider and further away from the median as compared to school A, okay, where the deviation, okay, how far it goes from the median 62 is actually smaller and lower, okay. So that's how we actually go about answering such questions. Alright, so again, this part we have our conclusion. And then the evidence as well. Writing. Okay, so I want us to take a look at exercise 3B question 13. That's in your textbook, page 104. Okay, I want you to give this question a try. Find the range, median, interquartile range. I'm giving over here discrete data. Okay, so individual data set, need to arrange them first so that we know the median and interquartile range. Okay, as well as the range. Then, okay, answer part 3. Okay, try answering part 3 itself. Part 4. Okay, sorry, no. Okay, never mind. You try to do part I and part 2 first. Okay? Then we jump into part 4. Okay? So just do part I and part 2. I got a new timer. It's a pig. But it's very heavy, just like I tried my other class. It slides down. Oh, it doesn't now. Okay, this one is better. Give it 4 minutes, okay? So 4 minutes to answer part I and part 2. Done? Okay, could we check answers before we jump into part 3 and 4? Okay, what would your range for x actually be using? Your range for x, 84, okay. So I hope all of us are able to get 84, that's 100 minus 16. Okay, then what about your median? What would it be, Sixuan? Your median? 51.5, great. Okay, so your 51.5, maybe let me just write the working as well. So 100 minus 16. Okay, and then your interquartile range, what did you get, Josh? Your interquartile range? 57. Okay, so your upper quartile and your lower quartile should be these values, and then you should get 57. Okay, what about for CTY? Okay, range of CTY, what will you get, maybe? 229. Okay, so we should have 308 minus 79, right? And then your median for Y, Carrie is not here. Really, what do you get? Median for Y. What's your median for Y? Not done yet. And can you nominate someone else? Oh, you remember your friend by the next number, not by name. Just worry. Station, yes, 11. 146, 121 plus 171 over 2 equals to 146. Does she call you 11? Then, really, what is Kiaing? What do you address Kiaing as? Okay, but not by next number. Okay. And then interquartile range. Okay, Diana, what do you get for this? Interquartile range? 97. So we should get 200 over here, 103. Okay, so these are the values that we are getting. Alright, let's take a look at part 3. Okay, part 3, it asks, okay, which city's data show a greater spread? Okay, so very clearly in this question, they're asking you to compare the spread itself. Okay, so the measures of spread that we have calculated, okay, are range as well as your interquartile range. Okay, so if you were to just do a comparison, looking at the range itself, right? Okay, clearly for city Y, the range is wider. And then looking at the interquartile range, the interquartile range for city Y is also wider because this is a bigger number than this, and your range is also a bigger number than this one. Okay, so what we can conclude is that city Y has a greater spread. Since both its range and interquartile range are both greater than those of CTX. Okay, so that's what we can conclude. Alright, so we're just making use of the range and interquartile range because those are the values that we already found in the question. Okay, usually if you're only asked to find interquartile range in the earlier parts already, then we just go ahead and compare interquartile range only. We don't need to go and talk about range. Okay, because range itself is a highly sensitive measure of spread. Like I mentioned already, because of the extreme values. Okay, so not a very wise choice to compare using spread. But just coincidentally, okay, the range and interquartile range for city Y are both larger in values than that of city X. Okay, is it possible for maybe the range being very wide over here and the interquartile range being very small. It is possible, but what can you conclude out of it? Okay, it really depends on the context. Okay, that you probably can conclude that the middle 50%, okay, people are more consistent. So maybe let me just write down. Okay, what if CTX or CTY has high range but small interquartile range? Okay, just write it in a very short form manner. You can say that maybe say CTY has a greater spread as a whole, but the middle 50%, the spread of PSI of the spread of the middle 50% PSI is more consistent, but the spread of the middle 50% PSI is more consistent to the median. This is because CTY has a greater range but smaller interquartile range than CTX. Okay, this would likely be your conclusion now. Okay. Right? This is from the spread itself, from the range. We draw this conclusion because of the range, and we draw this conclusion because of IQR. Shall we take a look at part 4? Okay, let's look at part 4. Part 4 is a very typical question also. Okay, they ask you to compare and comment on the air quality of the two cities, and they say give 2 reasons. Okay, so whenever you're asked to give 2 reasons, we always compare one that is based on their averages, that means their median in this case, and then the other one discussing on spread, which is on interquartile range. Okay, 2 comments, one on average, the other one on spread. Okay, so in this case, looking at the median, we see that the median for city Y is higher than that of city X. But so what if it is higher? We draw back to the context of the question. It mentioned clearly that a higher PSI reading indicates poorer air quality. So imagine yourself as a statistics reporter. Okay, that means you will find all this information already. You want to report it to maybe your boss or something like that. So put yourself in the shoes that you are maybe a weatherman or something like that. Okay, so you need to tell it to the audience, okay, or tell it to the nation what the air quality is like. So with the median of Y being greater, it means that city Y has a poorer air quality. So your conclusion is to draw reference to the context of the question, okay, if there is a context given to you. Understand? So, could I erase this part already? Are you this? I think not done with this part. Yeah, erase the top one. Okay, so when talking about the averages, we conclude that city-wide has a poorer air quality than city X. So whenever you need to report to your boss or your superior in future or whatever, okay, whenever you want to share something, you need to always provide a reason, alright? You cannot just state a conclusion, then the person will be very lost. So you need to provide your reason as well, okay? And that is because of the median value. Okay, because city Y has a higher median than city X. Okay? Do try to avoid the words like eats, okay? Because eat can be very ambiguous, especially in this case, there are two things that we're talking about. If you use eat, okay, then I may not know which eat are you referring to. Is it city Y or city X? The worst if you say because it has a higher median, full stop. Then how am I to know which is the higher median? Don't expect the reader, okay, or the examiner to be able to do that interpretation. Always try to be clear, avoid the ambiguity. Okay, so that is the first comment that you can make about the data. The next comment, okay, is about the spread itself. Right? So by observing the spread, we see that the interquartile range of X is smaller, interquartile range of Y is actually wider. Okay? That means that it can deviate more, okay, from the median for city Y. Okay? Unlike in city X, the deviation is actually smaller. That means that city X having a better air quality for most of the days, okay, because this one is over a period of 10 days, for most of the days the air quality is generally sort of more consistently better. Okay? So we conclude that the air quality of CTX is consistently better I erase all this on your average, okay, the other one on your spread. So usually how you can spot keywords about talking about spread is that we're talking about consistency usually. Okay, so spread is related to consistency, average is about as a whole, okay, in general. Alright, so with that, okay, this topic we are done with it so that we can move on to the next one. And with the end of our topic, that is homework. Okay, exercise 3B, question 8, 11, 12, 15. Okay, this shall be due on today is Tuesday. Can it be due on Friday? Friday? Okay. box and whisker plot, okay? In box and whisker plot, we're introducing another form of statistical diagram, okay? Because a box and whisker plot in general is a summary, okay, that comprises and shows you very clearly what is the median, the upper quartile, the lower quartile, and how the range is like. So it's a visual representation of all this information. Okay? It is easy to view a box and whisker plot. Unlike in a cumulative frequency curve, you don't have a sensing about the range, you don't have a sensing about the median, okay, until you go and identify the values. Alright? So in the box and whisker plot, okay, it can look something like that. I'm just drawing a very generic one. Okay, there is usually a number line. Maybe I'll use a different color. So there is a number line itself. So that it will help you to identify what are the values at these important junctures. Why are these important junctures? Because this juncture itself, where there's the tail, it tells you the minimum value, okay, of the data that we have. This part here, this line, tells you the first quartile, the lower quartile. This line indicates for you the median, which is also the second quartile. This line here tells you the third quartile or the upper quartile. And this line here tells you the maximum value. Okay? So why is it called box and whisker plot? Because we have our box over here, and then the tails are what we call the whisker. Okay? A box and whisker plot can tell you in a very visual manner how large the spread is for the interquartile range and how large the spread is for the overall range. Okay? So it really summarizes all the information. Okay? It may not have to be evenly spread out, meaning to say it may not be symmetrical. Okay? It can always be quite skewed to one side. So it depends on the data that you have. Generally, in your test or in your exam, you will not be asked to actually draw a box and whisker plot. Okay, but in practice now 5, alright, usually when you're asked to draw a box and whisker plot, right, they will give you a grid to draw on, okay, so that it is actually easier for us to actually go about drawing it accurate to size. We don't want to draw it inaccurate to size. Okay, so let me just run through how we go about drawing first. Okay, in part A we have this data set. So with any data set, if you want to actually draw a box and whisker plot, I must know what are the median, what are the interquartile range or the lower and upper quartile, and also minimum maximum value. So I need to arrange my data set in increasing order first. in increasing order, I can identify that the minimum value is 7, maximum is 29. Okay, and in this case, we have a total of 9 data values. Finding the middle will be the value 14. So the median is 14. Then to find out what is the lower quartile will be in between the 9s. That will be a 9 as well. And upper quartile will actually be between the 20 and 23. And we have 21.5. Okay? So now that we have identified the minimum, the maximum, the median, lower quartile and upper quartile, it will help me to actually go about drawing it, right? If you have graph paper, that's great, okay? But my objective over here is not to actually get us to really draw one, okay? We will have to draw it to scale. Right, so I'm just going to do a sketch. So I would choose a scale of maybe 6, 8, and 12. Really depends on your size of the graph paper. Okay, need not always start at 0. What it needs to capture are your 5 important values: minimum, Q1, Q2, Q3, and maximum. Okay, so we start off with having our line at 7, and then another line at Q1, which is 9. Our median is at 14. Upper quartile is at 21.5, maybe around here. Maximum at 29. Okay? So we connect our lower quartile and upper quartile together and draw in our whiskers. Okay? Then in part I, to find out the range from a box and whisker plot, I can read that the maximum is 29, minimum is 7. So range is 22. Okay. But obviously in this particular question, I can find the range and interquartile range from the data itself without even looking at the box and whisker plot. Okay, but there are cases whereby data values are not given to you. We are just given the box and whisker plot. We must know how to read one. Okay. And then the interquartile range would be 21.5 minus away 9. That will give us 12.5. So usually what I'll do is, if I'm given the box and whisker plot, I will recognize all the important values first. So I will always try to just label. Okay. Although if you're asked to really draw one, you need not label the values. Just make sure it's drawn to scale. Okay. I indicate this for me to do my calculation. same thing. Okay, I want to go into practice now 6 instead. Okay, looking at practice now 6, that's in your textbook, page 109. So a typical question involving box and whisker plot could look something like that, where they give you two diagrams. Sometimes they can also give you one box and whisker plot and then the other one cumulative frequency curve. Okay? Essentially, both of these diagrams help us to gather information about the median, interquartile range, and range itself. Okay? So very quickly, we look at finding out the range, median and interquartile range for brick A. Okay, I trust that you can calculate on your own and read the diagram too. So these will be the values you can derive out of this box and whisker plot. Okay? I want us to focus more on part 3, whereby the question asks on average, which type of brick is stronger? So the cue from this question is already to ask you to compare on an average basis. So we should be looking at the median values. Okay? The data values that we are given in this case talks about the PSI, the pounds per square inch, of two types of bricks. They in fact told you that the higher the value of the PSI, the stronger the brick itself. So by looking at the median values, I see that for brick B, the PSI is actually higher, a larger value. That will mean that the brick is actually stronger based on how they go about doing the comparison of values. Okay, so on average, look at median. We see that our median for B is higher, so we can draw that conclusion. So in part 3, we say that on average, brick B is stronger since brick B has a higher median PSI than brick A. Okay, so the justification is where you bring in the median into the discussion. Questions? Right? I want to end off by you going back just to do this one question. Exercise 3C, question 5. Okay? That's in your textbook, page 112. Okay? I want you to try writing out on your own, finding out the median, because we're looking at the cumulative frequency curve and the box whisker plot. Okay, form these kind of sentences on your own. Then tomorrow we come back. Okay, we check whether our answers are actually good or not. Alright. Looking at the current pacing, I would say that for our Thursday's home-based learning, okay, I don't want to give you a home-based learning on the next A-Maths chapter because after this we're going back to A-Maths. I think I want to start that by doing bundle teaching. Okay, so on Thursday home-based learning, just do your homework. Okay, manageable, right? Okay. That means tomorrow I also will give homework. Okay, tomorrow please make sure you have your calculators with you as well because I will go into standard deviation. We must know how to press our calculator.